Hi, welcome to this session. My name is Danilo and I'm part of the developer relations team in AWS. In this session, we are going to compare two very common architectural patterns that are used to build distributed architectures, and it's event-driven architectures and workflows based on state machines. Events are an example of a choreography pattern where there isn't a central entity controlling the execution of your application, but each component knows which events it has to listen to and what events to emit. Workflows is an example of orchestration where a central orchestrator is controlling the execution of the workflow. On AWS, we are going to use Amazon Event Bridge as a serverless event bus, and also we are going to use AWS step functions to execute our state machine workflows. The idea in this session is to build, using events and workflows, the same architecture and then compare what are the pros and cons of the two approaches. And this doesn't mean that you have to use always one or the other. And you can also use them actually together, and we'll look into that in the final part of the presentation. The architecture we are going to build is a very common order management system that we've seen in many customers, where we are going to build an API where you can create an order. The order is going to check if the item is available in the inventory. If it's available, it goes into payment. If payment is successful, it starts the delivery until the delivery is completed and the item is being delivered to the customer. This is something that you can build using events and workflows. So let's start in this first part of the presentation to see how you can build it using workflow and on AWS step functions. So using a workflow means that in any activity, I want to define what is my next step. So I'm doing the payment. If the payment fails, then this happens. If the payment is successful, then this happens. And I have to define what is the output that I need to send to the next step. So we are going to build a create order workflow that is going to interact with many microservices. We are going to use a direct integration with the Amazon API Gateway to create an API that you can use to create this order. And we are going to integrate with AWS and external services. So for example, we are going to use Amazon Location Service to estimate the time for the delivery and the cost of the delivery. And we are going to show you can integrate a fraud management system using events or workflows. We are also going to integrate with microservices that are part of this sample application, like the payment service or the delivery service that are supposed to be external services that integrate with your order management system. Microservices are going to be built with a web interface using the API Gateway. I'm going to use Lambda functions, but nothing is different if you use a container-based architecture. And we're going to use DynamoDB as the database. So let's start the application. And the first thing is customer says, I want to create an order. I can use the API to trigger the execution of the workflow, and then many steps are executed as part of the workflow. This is a view from the new editor in the step functions console. And this step can be successful or not. So sometimes you need to check the result of this step and take actions. You may catch an error or retry a correctable error. So for example, something can go wrong at the very beginning. Maybe I try to reserve an item in the inventory, but it's not there. So I can't ship the item to the customer and everything fails at the beginning. Sometimes issues come at the very end of the workflow. So for example, the delivery fails. So in this case, I need to take a list of corrective actions to roll back to the clean state. This is an example of what is called a saga pattern, and it's a way to avoid complex, large distributed transactions and replace them with small compensatory transactions that roll back each step that needs to be put back into the previous state. So for example, if the problem comes at the very beginning, you don't need to roll back a lot, but if something fails at the very end, maybe at the delivery, then you have to cancel the delivery, cancel the payment, take the item and bring it back to the inventory. So you have more compensatory transactions. The latter, the error happens into the execution of your workflow. I said error here, but this is a manageable error because if you deliver items, some items will not be delivered, and it's not something that you can avoid at all in all cases. So let's see now how this works more practically with some demo and some code. In the DynamoDB console, I have all the tables of my microservices. I used a table for each microservice, so I didn't use a single table design, but this doesn't change the result of this discussion. So, for example, I have a customer table where I have 3 sample customers. There's also their address so that we can estimate the delivery cost. Then I have an inventory table where I have 3 sample items, a smartphone, a TV, headphones. For each item I have the availability, how many have been reserved, and the price. So currently there's, for example, 10 available for item 1, the smartphone, 0 reserved, and the price is $3.99. So if I look at the other tables, like the order table, the payment tables, they're all empty because I cleaned everything before this demo. If we go into the code of the microservices, so I used a Lambda function, but this doesn't really change if you use, for example, a container-based application. I'm using the EventBridge direct integration for events, and we're using specifically for workflows the API gateway integration. So the step function will call the API using HTTP, no direct integration with Lambda functions. Here I use Node.js as the runtime. I'm using the new version 3 JavaScript AWS SDK with the DynamoDB document client to interact in an easier way with JSON and DynamoDB. And if you see, I have an environment variable that is called payment fail probability that tells me what's the probability of a payment to fail, to simulate errors. And currently, if we look into the environment variables, this is set to 0.5, so 50% chance that a payment fails or passes through. And then when we look at the event, all these microservices can work both with EventBridge and step functions with the API gateway. So with I look, for example, in the event, if there is a detail type inside the event, then I assume this is coming from EventBridge. Then I look into the event detail and the other information, and then based on the event type, I route the request to the correct subfunction, like to make a payment or to cancel a payment. If there is no detail type, then I assume this is coming from the API gateway, so I take the HTTP method, get is the only one implemented, and then from the path I take the path parameters, so the action and what the action is for, so for example to make a payment or to cancel a payment or to describe a payment. And if we look into the interaction with DynamoDB, I'm using the new PartiQL interface that is very similar to SQL, so it's very easy to read. So I select from the payment table to describe a payment. I insert into the payment table a value if I want to make a payment, and I update a payment if I want to cancel it based on specific conditions. To execute the statement, I use this utility function that is running and sending asynchronously the request to DynamoDB using the DynamoDB doc client. Similar to this, we also have the inventory application, and here maybe what is interesting to see is the atomic update that is very easy to use with the PartiQL syntax. So if I want to set an item as reserved, I need to decrement the number of available items and increment the one that are the number of the reserved, and I can do an atomic update with these 2 lines when I update the table. And there is also the condition, so if this item must be available, so the number of available items must be greater than 0, otherwise this will fail. And when I execute the statement on DynamoDB, I catch the conditional check failed exception. That means, for example, that the condition of availability were not met. I don't want to throw an error in that case. I just intercept the error and return an empty list to let the application know that nothing has been reserved. So now that we've seen a little bit the code of the microservices, let's see how we can interact with the order workflow. So I created this simple utility that will look into the output of the CloudFormation. Everything here is being implemented using AWS SAM, and then SAM translates data to CloudFormation. And the stack has its in this output has some information that you can use to interact with the application, like the endpoint of the URLs. So if I go here, I can run this command. I have to pass the name of the stack, and it will tell us the endpoint of the API. And now we can use the create workflow API to start and create an order. This is creating an order with an HTTP post for customer 1 and item 1, and is passing this as JSON to the endpoint of the create order create workflow API. Since payment can fail, let's create maybe 6 of those, and about 3 or something about that should pass through with payment. So now let's go to the step functions console. Here we can update, and we can see the 6 workflow that we started, and yeah, we've been lucky. So 3 are running and 3 are succeeded. The succeeded one, they terminated successfully, but probably the payment failed, and the 3 running are in delivery, into the delivery loop, waiting for delivery to complete. So let's look into one of the succeeded, where I assume payment has failed. So we can make a little bit more space here, zoom a little bit here, and then we can see what happens. So in each step. So if I go here and look into the output, I can see that the first step is to reserve an item. Then we get the price of the item, we get the address. Based on the address, we estimate the delivery and the delivery cost. Then we add these numbers together to have the total price, so cost of the item plus the cost of the delivery. And then payment, you see, is orange because it's an error that has been caught. And if we go here, we see that there are compensating transactions. So first I unreserve the item, then I format the payment, and I also write down the order for up to update the database that the payment has failed. And if we go into the DynamoDB tables, we can see that now we have 6 orders. These 6 orders, 3 are payment failed and 3 are still delivering, waiting for an update from the delivery service. If we go into the payment table, we see that we have 3 failed and 3 paid successfully. And if we go into the delivery table, we should see only the 3 that are in delivering, that are still there with a specific address, this is the address of the customer. So now let's, for example, look into one of these and see what happens. So let's go back into the step functions console, and let's take these 2 orders. So this one, the first one, these are still running, so they are in delivery. If we go into the details, we see that everything went as before, but this time the payment worked. So the payment is gone through, and now we remove the item for the delivery. We start the delivery, and then we write the order on the database, and we wait for 5 seconds. So if we go into, and that's why we see the order as delivering. And now there is a loop. So instead of the loop, I could have used the task token to create an asynchronous invocation. We'll see that towards the end of the presentation as a possible option, but I want to keep things simple here. So I have a loop, very fast, every 5 seconds. Maybe you can do it slower. And this is checking if this order ID is being delivered. So we can simulate the effect of the delivery service to say if this has been delivered or not. So first, let's cancel this order. So you have to pass to the endpoint of the delivery service the ID of the customer, is customer 1, and the ID of the order, that is depends on the specific order. So this is the order ID. The unique key for our order is customer ID plus order ID. That's the reason why I'm just using a timestamp for the order. So now we can call this, we get an OK. So this delivery has been cancelled. So if we go back here, we should see that, okay, the delivery loop completed. It has been delivered? No. And in fact, we see that we start with compensating transactions, more compensating transactions now. This is the Saga pattern, so we need to return the item, cancel the payment on the database table, update the order, and then we reach the final state that the delivery has been cancelled. So if we go on the DynamoDB table and we run the query, we see that we have one delivery cancelled. And if we go in the order table, we see that we have one item that has delivery cancelled, one order has delivery cancelled, and 3 were the failed payment. 2 are still delivering. So let's go into the other step function that we launched here. We are still in the delivery loop here. So we can click here, take the order ID. And then this time we want to send a delivered message to the delivery service. So this would be maybe the driver saying that the delivery has been completed. And again, we get an OK. If I send a random order ID, we get a not found. This is not found on DynamoDB. So let's go here. Again, the order now has been delivered, but we go on into the happy path. So we update the order as delivered, and then we close the order. So if we go on DynamoDB, we should see that now we have a delivered delivery. One is still delivering instead. And then in the order, we finally have an order that went through and has been delivered. So the order table is a sort of log of the order, a higher level of vision on top of what happens into the single microservices, and it's being updated by in this case directly by the workflow using the direct DynamoDB integration.
Hello, my name is Marcia Villalba, and I will be sharing with you the tips and tricks you need in order to design and develop an event-driven application. We will be building exactly the same application that Danilo was doing in the orchestration part, so you can see the difference. So, events are a little bit different. You will have an input for that event, and then that application needs to do something, a service, a component, as you like to call them, and that will produce an output event. And the curious things about events is that some events might not trigger anybody. They're just there. You produce them in order for future references or for future improvements or who knows what. Some events trigger one service or one component, and that's more our logical way of thinking, similar to the orchestration, because we go from one step to another. We have this kind of state machine. It's not the same, but in our head might work the same way. But sometimes events might trigger multiple services, and then that's the magic of the decoupling of the event-driven applications. You have multiple services doing their thing in parallel without knowing what is going on in the other services. And that's something we want to try to embrace and use as much as possible. So when we add a new service, you will see the advantage of using event-driven applications. So the first step when you're designing an event-driven application is to think of the individual components or services and what they are going to do. So think which events they are listening to. Which events is it one? Is it many that are going to trigger that activity? Then think what is the activity that service or component is going to do. It can be a very simple activity. It can be a more complex activity. In general, we tend to recommend that activities are simple and they are more granular. So they are easy to reuse, and then you can secure it easily and test them easier. But that's up to you and to your application. And then finally, you need to decide what kind of output events it's going to produce. So That's the first step. Make a list of what is all these activities and inputs and outputs. Also, when you're designing this, you might need to design what is in the information that you need in your input event in order to do the activity. It might be only one ID, and then with that ID, you might go into a database to find the rest of the information, or it might be the whole object with all the information. So your service can basically take everything from there and prepare the output. So in this part, we are going to use exactly the same 5 microservices that Nilo was using in his demo: the order, inventory, customer, delivery, and payment. And I will show you how these services, these microservices, interact with each other using events. So let's start with the same example that Danilo used, that is the create an order. A customer comes and wants to buy one product, and for that, they're using the web app, a mobile app, or something, and that produces an HTTP request. And that's kind of a synchronous request using API Gateway. That API Gateway triggers the Lambda function. And that Lambda function will use Dynamo to, store an item like, the order, and there it will put the customer ID, the one that started this process, the item that they want to buy, create an order ID, and put the status of the order. And now is when it comes to the different part. This Lambda function also will put an event into EventBridge. EventBridge is our service that takes care of handling the events within your application, and it will put the create order event. In there, it will send the information like the customer, the order, and the item ID. And then EventBridge will analyze all the rules that are configured within EventBridge, and it will say, well, if the create order is the type of the event, then we need to trigger the inventory service and the action reserve an item. And then the item will get reserved and things will start happening, and this gets very confusing very fast. I'm pretty sure you have tried to diagram an event-driven application. They don't work. Unless you're animating everything and make it look pretty, it's just very hard to document with diagrams. So my recommendation is to use a table to start designing your event flows. And with this table, then you will have a clear path and you will be able to follow the events from the output to the input and what actions they are triggered and what is going on. So let's look at an example. This is the same example, the create order, and this you will see that it's in the API column. It says create order because this is the output that we are getting from the API gateway from the HTTP request. And this will be the only event that is has a connection with an API. The rest of the events are basically in our input event as triggers. This triggers the create order and in the service order, and it outputs the order created. Then we go to the next step. The order created will reserve an item, and it will put an event of item reserve if everything goes fine. The item reserve, then we'll go again to the inventory and get the price for the item using the describe item operation, and then it will get the output event of item describe. Now the output object will have the price of the item and other information in the object. That can be taken, and then we can invoke the next step, and so on and so forth. And here you can start realizing that many things can happen. The first one is what we could have collapsed these inventory calls, like the reserve item and the describe item into one. Yeah, maybe. Why we do two? Well, as I mentioned before, we like to keep things as simple as possible for reutilization purposes. Other things we could have done, well, we could have run in parallel. We don't need the price of the item to get the address. They are independent to get the customer information. So we could have done that in parallel. Yes, we could have done, and we could design that. Also, how you build this table, well, that's up to your business logic. You need to understand what is the problem you're solving. Well, in our case, we are trying to create an order, so we want to make a payment. We want to make sure that the customer gets a product. So all these things help us to decide what are the activities that we need to do. And sometimes you might not build this table in one go. This is the nice thing, that this is a table that you build in a spreadsheet, so you can modify it and play with it and change it until you find the optimal table, and then you go to your code and you implement it. So also, don't forget when you're implementing this to handle your errors. So when you think about the happy path, like the item is described and the customer, we get the address, then we start a delivery and the delivery goes. That's great. But what happens if the payment fails? What happens if the delivery fails? Then we need to do the compensatory action like we do in the Saga patterns in the orchestration in order to revert what we have done. So for example, we have failed the delivery, so now we need to reimburse the customer. We are getting back the money back to the customer. We need to put the item back in our inventory. So all these things need to be taken in account. And with that, I want to show you all this and more in a demo. So let's jump into there and see it in action. So to start the demo, what I'm doing is going to GitHub and basically cloning that repo. And then I will be just building and deploying this into the cloud. So then everything is ready and we can get started. After we do the deployment and we get everything in the cloud, we are going to go to template YAML. In the template YAML, you will see all the resources that are going to get deployed in our AWS account. And you can see that there is comments for the different bits and pieces. And the first one is the event bus. So we are going to define an event bus specifically for this application. And we are going to name it app event bus and the name of the stack which will deploy the application. So this will make that all the messages that are being sent in this application are going to be separate for any other application. Then we can go to the order microservice. Everything is defined in the same template YAML. So the order microservice has an order table and then a huge function that does a lot of things. And if we open the function, we can find the code for that function, and then we can see how that function gets triggered. And because this is the first event in our application, in our demo, it will be the external API that we are getting through the web application or the mobile app. And that will be an get, where we are going to pass the order create and the customer 1, for example, and the item 1. And then if we go to the code, we can see what is going on there. We can go to the beginning of the Lambda handler and then check what happens in the API invocation. And then if the method is get and the action is create, we are going to create the order. And in the method create order, what we are going to do is to build the order object. We are creating an order ID based on some date, the current date. And then we are going to create a JSON object with the order ID, the item ID, and the customer ID that we are getting through the request. And the next step is to send the event using Event Bridge. And there I'm passing the order created, that is the type of event. And then the detail is the order. And there we are going to build the event that we are going to send. We have the envelope part, that is the detail type, that is basically create order. Then the event bus name, that is the event bus that we just created. Then the source, in this case is order because it's the name of the microservice. And then the detail, that is what is going to go inside the event. And in this case, it's just the order. And then we are going to use the Event Bridge client and we are going to send that into the bus. Then if we go to our documentation, we can go to the template table. This is the design table where you can see all the events as I show you in the presentation. And here you can see the external API create order and the action create order, and it outputs an event order created. And this then is consumed by the inventory service and the action reserve item. So if we go there, we can check what is going on in the reserve item. And we can see how it goes. So again, in the template YAML, where all our infrastructure is, and then we go to the inventory microservice, and we can see the inventory function, and there we can see how this function gets triggered. This function in this particular case will get triggered by an event of the type order created. And there you can see that when you're using SAM, you can define the the triggers of the events also if there are rules from Event Bridge. So here you can put what is the pattern that we are looking for. In this case, we are just creating the rules based on the detail type, but you can create more complex rules, and that's totally fine. It's possible in here, but here basically the only thing we are doing is the order type matches, order created, order cancel, item reserve, or payment made, or payment failed. Then we are triggering this function. And then we go to the code of the inventory, and we can see that if the event type is the type of order created, the event is the type of order created, then we are going to reserve an item. Reserve item is just using a particular statement in Dynamo. So as Danilo explained already, you can use SQL into Dynamo. And in here we are just updating the availability of this item, and we are marking that one item is reserved, and we are executing that statement in the Dynamo database. So after that is completed, if everything goes well, then we can process the result. And you can see that there is item reserved and item not available there. So those are the events that we'll need to output. Item reserved if everything is good, item not available if there is any error. If there is something in the result, meaning that the, operation of reserving an item went fine, then we are going to send an event with the OK event, in this case, item reserved. And if there was an error, then we are going to send the event with the KO event output. And again, this is using the same type of function, send event, and is building the event package to send to Event Bridge. If we want to try this out, I'm using this auxiliary library that we have in our GitHub repo. Inside the info folder, you can run this get API endpoints and pass the name of the stack, and that will return all the endpoints for your for the different microservices. So just get that API and invoke it. I will just invoke it with curl, and I will create a new order for the customer one for item one. So we are basically only buying one item at a time to simplify. So in order to show you the logs and the Dynamo tables, I want to use an extension from Visual Studio Code called Serverless Console. The extension is great, so you can get it from Visual Studio Code just by searching Serverless Console. And this extension is really handy for doing logs and also DynamoDB tables to understand what is in there. So in order to configure, after you download that and install it, then basically you can configure a new application by selecting what kind of source of deployment, the profile that you want to use, a title for it. In my case, I just put it events, but you can have whatever you like. You can specify the region, you can specify the stack name that this is going to let the logs and everything. And so in my case, I just did it, and then I can see in the side all the functions and then all the Dynamo tables. And if I open the logs for the order function, then I can see there all the logs. So I don't need to go to any CloudWatch console or anything to see what is going on. So I can see that there is 3 logs for the order function, and we can try to read them, what is going on. But, you know, sometimes the logs are not very descriptive because it just depends on what we are logging, and it can be kind of confusing. So I really don't know what just happened in here. But you can go to the code and check it out. Then we can check the table, the order table, and there we will see that there is one item, and that item is the one that we just created. The order ID is based on order ID, and you can see that there is some information for that order. So you can see the order status, that is delivering. So something happened. I'm still not sure what, but something happened. Then we can go to the inventory table because that's the next microservice to get triggered. And there we can see that we have some logs. And again, these logs doesn't say much. It means like the function was invoked like 3 times, but I don't know much. And then if I go to the inventory table, I can see that that nothing is reserved. I don't know what happened. Maybe from the item 1 I sold one. I'm not sure. How to know what has happened here? Because events sometimes are a little bit tricky. Sure, you can rely on the logs, or you can rely on your knowledge. But one great way to understand what is going on is to have like a source where you will have all logs of all the transactions that happens, of all the events that flew. So for that, I'm going to create an event store table, and that's another Dynamo table, and I'm going to show it to you in a moment, where we are going to store all the events that go by our event bus. And how we capture all the events that go by through our event bus? Well, with a function. And this function is the event store function, and basically it will get triggered with any event in our bus. You can see the pattern for the rule, and it means that it matches all the events. Basically, whatever event goes inside the event bus that we created, it will trigger this function. And this function then will save the data into this DynamoDB table. So we can see the code, and we are formatting the data that we want to put in the Dynamo table, like who was, at what time, what was the information, and then we will just insert it into the table. And also, to make life nicer and simpler, we are writing exactly what we are going to put into the table as a log, so we can also see the logs to understand what is going on. So then if we go to the logs, and we go to the logs of the event store function, there we can see that we have quite a lot of activity in there. And if we open the first one, you can see that the order was created, and we can start tracking what just happened. So the order was created, and basically it's the order service saving that order information into the order database. Then we have the item was reserved, and this is the inventory service, basically reserving an item into the inventory database. And then moving on to the next step, that is the item describe, and basically here we are getting the price of the item, and you can start seeing there that there is some information of the item, how many they are reserved, and what is the price that we need in order to pay. Then we have the information for the customer describe, where we are getting the address of the customer in this case. So then the customer, we can estimate the delivery for the customer. And then we will basically call the estimate delivery. And these are all the events that are getting captured by this service. And if you go to the service, you will be able to see that all these functions got triggered and did something. But this is so much easier to understand. And finally, we can see that the delivery has started, and then we don't see anything else. Because now it's in the hand of the third party that is doing the delivery, that needs to notify us when the delivery is done, that happened, and then we can go. So we see that the status is delivering, and that's the last thing we know from this order. If we go to the event store table, there we can see the same information in the format of a Dynamo table, like who was the person, the customer one, or whatever customer ID, in which time, and then what they did. In this case is the order type, order created, item reserved, item described, and then we have all the event information and then the event source. So we get all the information that trigger the different events. So this is super handy to understand what it was going on in our application. So we're gonna open any of these items, and we can see that there is a lot of information, like, okay, the customer one, order created, and this is the information that we got out from here. Let's get the order ID, and let's see what happened to continue the delivery. So if you want to continue the delivery, you can go to the data and start delivery, and there just put the right event bus, the source, it can be logistic, whatever third party you want, then the details, put the right customer ID and the right order ID for the orders that you want to kind of deliver. And then you can put the detail type delivered, and we can see the happy path here. Then you can basically run this, and for running that, I will be using the AWS CLI. and that will put an event into EventBridge through the terminals, and then poof, that's get put, and then we can see the logs again and see what happens. So we can go to store table, and there we can see that now we have the delivery started, and now we have the deliver message that we just sent. Delivery was delivered and order was delivered, and then it finished. And then if we go to function logs, we can see that that things are happening as well, that then the logistics sends that it was delivered, that's good. And then we can see that the delivery was delivered, and that updates the table, and then the order updated as well that it was delivered. So you can follow the events in the table that we designed at the beginning. But what happens when something goes wrong? So I will create a new transaction with customer 1 and item 2, and then I will send an event that says the delivery is canceled. So basically, like the customer was not at home or there was some problem. So I will just change that deliver event with delivery cancel, because for some reason the delivery company could not deliver. So now the package is back at our premises, and we need to do all the compensatory actions that we did, because we have reserved an item, we have paid, the customer has paid, we have done quite a lot of things, so we need now to revert everything. So I will execute that and put that message again in the event bus, and then we can refresh, and you can see that delivery started, the delivery got canceled. That's the event we sent. Then the order was canceled, the item was returned, and the payment was canceled. And these are all compensatory actions that we have to do. So this is very important when you're working with any application, that you always do not only the happy path. So I hope you liked the demo and you learned a lot of new things on how to design your event-driven application. Now it's time for Ricardo.
An interesting way to find out a little bit more about the differences between our workflow and event-driven architectures is to understand what happens if we need to make any changes, for example, needing to add a new microservice. Perhaps we might have some new requirements that we need to add. From the previous example we've seen, maybe we need to add a new notification to let us know when the delivery has started or been made, or perhaps we want to check payments against fraud and we want to use an external fraud detection service to help us with this. So looking back at the order workflow, the first thing we need to do is figure out where in the workflow we want to add these new steps. Then we need to make sure that we have all the right information as inputs to that step. For example, do we have the delivery date details or contact information or payment details? Now, if we do, great. If not, then we need to figure out how to input that information so that we've got the information for that step. With the event-driven flow, we need to understand whether we can listen to existing events. For example, the start delivery event generates a delivery started event, which we might be able to use, or perhaps the make payment action will generate the payment made event, which we can listen to trigger a new action called check fraud. If there aren't any existing events that we can listen to, we need to create those and change the necessary services. So to wrap up this session, here are some key takeaways. We have seen that we can use different approaches for getting microservices to work together towards a common goal. It often makes sense to use events as a way of managing the interaction between multiple services, where you might use workflows to manage and control the interactions within those services. We can use the analogy of a conductor managing an orchestra versus a group of musicians who are jamming together to create music without a lead. If you need to implement services in a distributed transaction, then workflows can help with strict coordination that's required. And we see this in a common example where you need to roll back transactions using the saga pattern. So using our example earlier on, if a payment or delivery fails, then we need to figure out how to roll back inventory or payment states. Now, it can be easier to start with workflows, as you can typically draw the steps you want to implement as your business process. With events, you actually need to think about all the different business events that you might have. The flip side of this is that adding new functionality is simpler with events, as they are less coupled than workflows. Now, when we work through the workflow example, we do not cover a way of integrating with asynchronous steps in our workflow. So in our example, we might want to pause our workflow during the out for delivery and delivery step, or when we call an external service to do something like fraud detection. Now, this blog post from AWS serverless hero Sheem Sals shows you how you can use callbacks to task tokens that help pause a workflow and then resume when the callback token has been received. It's well worth reading to understand how you can use this within your own workflows. And the blog actually goes on to show how events and workflows can be used together, for example, using the integrations provided by Step Functions and EventBridge. And you don't have to choose which one to use, but you can mix and match them within your architectures. So that concludes this session on using events and workflows to build distributed applications. We showed you how you can integrate different services together using an event-driven architecture using Amazon EventBridge and workflows managed by AWS Step Functions. We shared how to think about both of these and how they differ when it comes to needing to change or add new features, something that is common as your application requirements change to meet your customer or business needs. Now, all the code that we used in this presentation is going to be made available via GitHub on this repo, so you can implement this for yourself. Feel free to raise an issue or pull request with any suggestions for improvements. So with that, thank you very much from us, and I hope you enjoy the rest of the reInvent sessions.